Alright, I've got some slides here. Physics, Part 1, Mechanics, Lecture 1. There we go. Dimensions and units. So that's what we'll be having a look at today. So usually I try to do 2 lectures in a double class. And we can try and do that today, but for the first class, sometimes I go a little bit slower. So we'll see how we do. I know not everybody is here yet, so I don't want to go at full speed, because I think there's 2 more students coming for this class actually. Anyways, first thing to do, write down the title. So we're looking at units and dimensions. No, don't do this. No, write it down. Pictures are forbidden. Okay. You haven't? Write it down. You came to school without a pen.
I lost all my bag last time.
Okay, but there's a shop across the road. Okay. Where are we? Here. Now it's stuck. Oh my goodness. It's been a long holiday. See, because it's been a while since I turned it on, you can see it's doing all this type of stuff, like trying to synchronize the Dropbox folder.
Yeah,
this is my first class now since before Christmas, so this is why. The last time I used this was 3 weeks ago. Possibly, what do you think if I close it? Will we open it?
It didn't close yet.
Yeah. Wow. Come on. And now it's closed. Now it's opening again. Oh, goodness sake. Wow, what a bad start. That's actually the wrong one now. Okay.
Try opening with a different application.
Yeah, maybe. The Adobe one displays it the best for all the symbols and things. Here we go. That's better. Alright, you got the title now? That should have been more than enough time to write the title down. Okay. So, and there's a lot on this slide. You don't need to write it all down. I'm giving you key vocabulary. So, a unit is a reference system used to measure a quantity. So, for example, length, mass, and time. These are called fundamental dimensions. So what I'm trying to do here is to show you what the difference is between a unit and a dimension. It'll become clearer in a minute. Length, mass, and time they're called fundamental dimensions. So, for example, the meter, that's the unit. Hey, you're bringing down my two physics students?
Is it? Yeah, it's right here.
Yeah, no, this is physics, yeah.
Hello.
Great. I'll just sit anywhere that's handy, okay? Yeah, trust me, this is physics, I know. So, good news is this is the first slide, you didn't miss anything. So, for example, the meter, that's called the unit, and that's measuring length, which is called the dimension. So, can you see the difference between the two? The meter is what's called the unit, and the length is what's the dimension. Can you see the difference? Yeah? So other dimensions exist, and they're created from these three fundamental dimensions. For example, area is length squared, for example. Alright, so just before I go on, you might want to note the two key words are unit and fundamental dimension. And an example for the difference is, this would be like a meter, and this would be like length or mass or time. Okay, so please just make some note on the difference between the two. Why do you think these ones are called fundamental dimensions? What do you think the reason might be? Any ideas?
They're the base of...
Yeah, like they're the base. Length, mass, and time, they're the basic ones. Now, the size of a unit is called the magnitude. So the word magnitude just means size, how big. So if I say what is the magnitude, that just means how much. Okay, so magnitude is a noun. It just means how much.
The size of the unit?
The size of the unit, yeah. Okay. So have we got those keywords? Unit, dimension, and magnitude then? Yep. Okay. So, nobody's American. No Americans, right? So, your home country will also use this international system of units, which we use everywhere except America. So it's the metric system, and we've got in total 7 basic units, and most of them, maybe all of them, you know. So the first basic unit of the 7 is the meter, which you all know, of course, and the meter measures what dimension? Length, which we'll call L then. Okay, so if you want to write these 7 down, first one is meter for length. Good, yep. Do we know any more?
There's ground for...
Yeah, and time, yeah, so the next one, they're all of them, yeah. What do you think the next one would be after meter, like kilogram or maybe something like seconds? So kilogram is next, and kilogram measures what? Mass, yeah. Now, please note, technically, it's the kilogram and not the gram that's the base unit. Okay, next one is the second, which of course measures time then. Yep. Now, on to the more interesting ones. So the next one we have is called the amp. Now, you might remember this if you've done it before, but what does the amp measure?
Not the current.
Not the current? Perhaps it is the current. Yeah, so the amp measures the current. Yeah. So for example, something like this, I think it's at most 13 amps. Although this is probably only like 5 amps, something like this. You remember this one?
Yeah.
Yeah? Okay, next one. Yeah, which is the Kelvin. You know Kelvin?
Yeah,
Hmm?
I wrote Celsius.
You can use Celsius, but I think technically it's the Kelvin that's the base unit. And this measures temperature. Okay. How many have we got? 5. 2 more to go.
Light intensity.
Light intensity is 1, and what's the other one?
Pressure.
Mm-hmm. Anyone know? The next one is the mole.
Yeah.
And what does the mole measure?
Amount of particles.
Yeah, it's a quantity. Amount of substance, yeah. You probably would see the mole more commonly in chemistry, yeah. And you're all doing chemistry. Okay, and the last one you said, do you know what the unit's called though? For the one you said. Want to have a guess?
I don't remember.
No, the last one is called the candela, and that measures the intensity of light. In other words, the candela measures how bright something is, the brightness. The last one is not something we'll use. Only the first 6 we'll use. Have you seen this one before? Candela? What word does candela look like? Looks like candle, yeah. Have you seen this one before? Candela? Most people haven't seen it before. We don't really use it in physics class. Okay, we got this? Yep. Continue.
Is that a J for the symbol?
Yeah, J for light intensity. Yeah. Okay. Next slide. Alright, so some basic rules when it comes to dimensions. Quantities of the same dimension may be compared or equated. So what I mean by that is, for example, you can say something like, I don't know, 5 meters equals 5 meters, or 2 meters equals 2 meters, or 3 meters is bigger than 2 meters. But you can't say 3 meters is bigger than 2 kilograms. Why not? Why? What's the problem there? Different dimensions, different units. So that's what I mean here. Same dimension, you can compare them or make them equal. So for example, I could say 1 meter plus 1 meter is smaller than 3 meters. But I can't say 1 meter plus 1 meter is smaller than 3 seconds. That doesn't make any sense.
When you say 1 meter is equivalent to 100 centimeters?
Yeah, that's fine. Yeah, because they're both the same dimension of length. So you can add or subtract, multiply or divide if they have the same dimension. You can do anything with the same dimension, okay? But if they're different dimension, you cannot add or subtract them. So 5 meters plus 2 kilograms, not allowed. This isn't up yet. And then if they're different dimensions, you can still multiply or divide them. So it's okay to say 5 meters divide 2 kilograms. You're allowed to divide by any dimension. So you can compare or make them equal, add or subtract. You cannot add or subtract if they're different, but you can multiply or divide if they're different. Okay, so you want to make some note here of the basic rules. You can write all this down, or you can just write some examples down of what you can and can't do. But you should write something down about the rules here. The key thing is, if they're the same, you can do anything, and if they're different, what can you do?
Multiply and divide.
Only multiply or divide, yeah. Okay, not yet. So, just to write a little example down. So you could say something like 5 meters is smaller than 6 meters. That's okay. You could say 5 meters plus 6 meters. That's okay. 5 meters minus 6 meters. That's okay. And of course you can multiply and divide them. 5 meters by 6 meters. That'd be 30 meters squared, and then 5 meters divided by 6 meters, what would that be? 5 over 6, yeah. But you can also do something like 1 kilogram multiplied by 2 meters. That's okay to do. Different units can be multiplied. The answer would be 2 what though?
kg.
Yeah, meter kilograms, or kilogram meters then. Okay. So let's have a look at what's next then. Do you have this? Yeah? Right, so a couple of questions. We can just do them together now. I'd like you to write in your book if the following are valid or invalid. In other words, are you allowed or not allowed to do the following? So for example, the first one is valid. You can do it. Yeah. Okay, so if you can write the answers down in your copybook, and then we'll go through them together. It should only take you like 1 minute. Okay, you got them?
Yeah.
Right, so A we said is valid. What about B? Valid. And C? Not valid. D? Valid. E? Not valid. And F? Valid. The last one we can do, yeah. Okay, so this time I want you to tell me what is the dimension of the following, and the only thing I tell you is X has dimension of length L and M has dimension of length mass. So I tell you that X dimension is length and M's dimension is mass. And for example, the first one is, what is the dimension of W? So what's this dimension here? So I was wondering if anyone has any
Then,
ideas. Yeah, but why length?
because we can only add the same unit.
That's it. Because I'm adding here, these must be the same. Now we know that x measures length, so that means this must also be length, and this must also be length. Therefore, this has to be length. So we know for the first one the answer is length. You get the idea? So I want you to try these ones now, see if you can get the unit. You can use, by the way, you can use the answer from the last part in the next part if you like. Okay, so we know x, y, z now is length. How are we doing on these?
Yeah.
Yeah? Finished?
Yeah.
Okay, so what's B?
Length.
Length squared.
Length squared.
And C?
Length cubed.
Length cubed. And then the last one, D?
Length to the power of minus 2.
For the last one,
Yep.
you might be missing M in there.
The M is L.
Is
and
it?
D is.
The M is...
Oh,
M.
okay,
Yeah.
never mind.
So we have a look at the last one here.
It will be M.
Yeah.
L cubed.
M over V. Now, the V, you know that's the answer for part C, which we said is
L cubed.
L cubed. And then the M, I tell you in the question, is M. So the answer, we write it like this. Is of dimension M slash L cubed, but I don't actually like it like this. It's more normal to write it like this, minus 3. Okay, so this is the answer for part D. We have to use the previous answer and the information in the question. So this is the answer. Okay. Continue. Yep. So what I want you to do next, same questions, except this time tell me what the units are for each. So beside each answer you have, just write down what the units are. Okay, so the first one, what's the unit? Meter. Second one?
Area.
Yeah, which we'll say is meter squared. The third one, which is volume, is meter cubed. And then the last one is...
kg per meter minus 3.
Ooh, close, not quite that, because you used the word per.
Yeah.
Oh.
You said kg per
Oh.
meter cubed. So if you say this word, you don't need to say the minus here. Yeah. So it's the same thing as this. kg m minus 3 is the last one. Okay. Now the last one you might actually recognize it. The last one looks familiar maybe? Have you seen the last one before? Yeah. The last one's actually something called density, which is this symbol. And it measures mass per unit volume. So in other words, this is like our first formula. density is mass over volume. The dimension is mass per length cubed with units of kilograms per meter cubed. Now, we will try not to use the slash, okay? Try to use the minus power. Try not to use this. Try to write it like this, okay? So not this, like this. What did you use in your school? Slash or minus? Minus? Both? What? Both? Slash, okay. So for...
It's the same, no problem. It's the same, no problem.
It's not the same, it's the same. But in the exam, they only want this. They don't like this for the exam. So we'll try to get into the habit of using the minus. Okay? Okay. You can write this down. This is I think what you need is the word here. This is called density, and this is the unit. Does anyone know the name of this Greek letter? Not phi, not that one.
Rho.
Rho it is, yeah. Do you know your Greek letters? Forgot them. This one?
Alpha.
Alpha,
Beta.
beta. No. Which is this one?
No, this is gamma.
Gamma, yeah.
Yeah.
Delta.
Delta. Sigma.
Oh no. Epsilon. This one's sigma. This one's mu. This one here is theta. This one is phi. This one is psi. This one is eta. This one is nu. This one's omega. Okay, so if these, we know this one, and we know this one. Yeah, okay. So we'll learn them as we get through them. This one I just wrote is called rho. Maybe you want to write that one down. Yeah. This one, actually, you seen this one before?
For the vector, yeah.
Yeah, do you know what it's called?
No.
Iota. Yeah. Anyways, the one we have right now is called rho. So sometimes I will say density, sometimes I will say rho. Okay, let's continue. The litre is not really a unit we're supposed to use. It's not really an SI unit. I don't know if you knew that. You probably used litres before, but actually the litre is not a SI unit. So that means whenever you have a litre, you need to convert it into something else. What does the litre measure though?
Meters cubed.
Oh yeah, what's the dimension? What's the thing it's measuring?
Cube.
Liquid.
Yeah, length cubed, which is volume.
Fluid.
Volume, yeah. So what will be suitable to replace the litre by is something like meter cubed. So the rule is 1,000 litres equals 1 meter cubed. Okay, so for this question, what is the density of water if 1 litre of water has mass 1 kilogram? Okay, so can you write this question down? This is our first question. True. 1 what though?
1 kg meter.
True, that's true. The reason I'm doing this question, I know it's simple, but I want to show you the way to convert units, like the steps. So if you can write this one down, and then I'll write the answer on the board. So the question is just, what is the density of water if 1 litre has a mass of 1 kilogram? Okay, will we have a look at it now? Yeah? I'll write the answer down. Or do you need a bit more time? You have this?
Yeah.
Yeah? Yeah? Okay. Right, so what's the formula for density? Mass over volume. Now here, the good news is we know the mass, it's 1 kilogram. And we know the volume, it's 1, but the problem is it's 1 litre. We don't want litres, we want meters cubed. But 1,000 litres equals 1 meter cubed. So that means 1 litre equals 1 over 1,000 meters cubed. Can you see that? Can you see what I did there? I just divided by 1,000. So I can take that and put it in here. So we get 1 kilogram over 1 over 1,000 meters cubed. So the answer is actually 1,000 kilograms per meter cubed. Now I know what you were thinking of when you said 1.
Yeah.
It's actually the same as 1 gram per centimeter cubed.
Yeah.
But in kilograms and meters, the answer is 1,000 kilograms per meter cubed. Okay, can you write this answer down? So this is the way you should be answering this in the exam. You got this yet? Yeah?
Isn't the liter already meter cube, 1 meter cube?
It's not. It's not.
1,000 liters is 1 meter cube.
Yeah. We shouldn't be using litres, that's why we need to convert it. 1,000 litres is a meter cubed. 1 litre is 1 kilogram of water.
Yeah.
And 1 centimeter cubed of water is 1 gram. Okay, continue? Alright. Come on. Alright, so next now. Right, has anybody heard of this word before? Prefix. You might know prefix from English as well. Prefix?
Yeah.
What's a prefix? How would you explain a prefix?
Kilo, milli.
That's it, these are all prefixes. What about in English? What's a prefix?
Adjective you add before.
Something you add before, yeah. So you can have happy and then unhappy, or you could have try and then you could have retry. So these are called prefixes in English. And we have something similar in physics. You know, we have meter and then we have kilometer. And how much is a kilometer? It's 1,000 meters. So let's have a look at our units. Of course we know kilogram and what else, centimeter and all of these. So let's have a look at the ones you need for the exam. We'll start with the big one first, giga. What letter is giga? What letter do we use for giga?
G.
G. Big or small?
Big.
Big G. And how big is it? How many zeros?
Times 10 to the power 6.
Not quite. More than that? 9. Yeah. So giga is 10 to the 9. So that much. Okay, so that's the first one if you can write it down, giga. So we'll go from the biggest to the smallest that we'll use. So what's the next one under giga? Smaller, mega, yeah. And the letter? M. And capital M. And how many zeros? 6. Yes, this one's the 6. What's after mega?
No,
Mhm.
no.
Kilo.
Kilo. What letter?
One we
Okay.
use deca and deco and
Oh yeah, we'll get there. Yeah, yeah. Kilo.
Okay.
K.
K. 10 to the 3, 1,000. Now, deci and deca, we don't use those in this course. I don't know if you might use them in chemistry, but they're not part of our course. Okay, so the next one after kilo, we go to the small ones now. Centi, like centimeter. What letter? C. And then how big?
10 to the power minus 2.
Minus 2, very good. 0.01 is a centi. Right, now, so now we're getting smaller. So, what's after centi? What's next? Milli, which is an M,
Minus 3.
minus 3, yeah. Next,
Micro.
micro. What letter is micro? Yeah, what's that called? Mu, yeah. Mu. And how big is it?
Minus 6.
Minus 6.
Then it's nano.
And last one we'll have is nano, which is an N, which is 10 to the minus 9. Okay, yeah. Got that? Yes? Yeah? Yeah. Okay, now, I'm sure there were many ways you saw how to convert units in high school. Okay? Probably most of you saw the wrong way to convert them. The way I'm going to show you is the way I would like you to try and do them in class and in the exam. And trust me, it's better for you this way. So I think in high school sometimes students learn things like, oh, you multiply by 1,000 or you divide by 1,000. You know, if you want to go from meter to kilometer, you multiply or you divide or whatever. This is the wrong way to think about it, because if you think like this, you have too many possibilities to think of. Okay, so this is a simple example to show you the steps on how to convert. So we'll do this one, or I'll do this one if you can write it down. It's convert 50 kilometers per hour into meters per second. Okay. Can I do this one? Okay, so we start off by writing down what we have. 50 kilometers per hour, which as a fraction is 50 kilometers over hours. Now, the way I think about these is prefixes. These are just like numbers. So for example, you can change this into 50 times 1,000, because I said kilo is 1,000, over meter, over hour. But hour, we can think of as 60 minutes, and then minute we can think of as 60 seconds. Yeah, so in total it's 3,600. So 50 times 100 times meter over 3,600 times second. So if I hit this in on the calculator, I get 13.89 meters per second. Now that's a very simple one, but it gives you the key idea. You treat prefixes like they're numbers. They have a value, a number value. You know, the way we think of pi as being about 3.14, we should think of prefixes as just being of number value. Okay? We'll do more difficult ones now, but that's a simple one just to start with. So if you can write this down. Okay, we have this? Yeah? Okay, let's have a look at the next one now. Now, this one's getting much more difficult. The square makes a big difference here. So if you can write this down, convert 50 centimeters squared into meters squared. Okay. 50 centimeters squared into meters squared. Now, before I start, in math class, you know if I write this, that is not this. That the square is only on the y. However, in physics, when you have a unit squared, like for example cm squared, that does actually mean c squared m squared, that the square actually is on both. We don't write the brackets on the units, okay? So that's the first thing you need to know, that the square is on both. So square on both in units. Okay, so now that you know that, it'll make the question a little bit easier to do. So we have 50 centimeters squared. That equals 50 centi squared meter squared. That equals 50 0.01 squared meter squared. Okay so far? That's equal to 50 0.0001 meter squared, because that's what happens when you square it. So, where's my pen gone? I can't see. Oh. Use my mouse for a moment. 0. Now let me think if I get this right. 2 zeros and a 5, isn't it? Yeah. 0, 0, 5 meters squared. Okay. Have you seen it done this way before? No, never. What way would you have done it in class?
Write the conversion and then square off.
In other words, a lot of effort.
Yes,
It was
Yeah.
very complicated.
Exactly. You probably have to write something down like 100 centimeters by 100 centimeters equals 1 meter squared, or something like this. This is what I'm trying to get you to forget from high school. This is just much easier to do it this way, okay, which you haven't seen before. Yeah, so if you can write this down carefully, this is the way you should be converting units. Okay, you got this? Yep. Okay. next now. So what we'll do, this is, I think, see, what I normally do is I give you homework and then we'll do the answer in the next class. But what we could do today is maybe we can work on the homework together. So for example, you could do question 1 and then I'll do it on the board. Then you could do 2, then I'll do it on the board, and then you do 3 and then I'll do it on the board. So in the first one here for homework, which we'll do now, I tell you D is for length, is measuring length. T is in dimension time, and which is seconds. So sorry, D is length and meters, T is time and seconds, and M is mass and kilograms. So I want to know what the units are for each of these. So the first one, U equals D over T. Okay, well what's D? Length, yeah. And T? Time. Yeah, so that would be meters per second, yeah, which is speed, but you don't need to write that down. So the answer here will be length per time, which is meters per second. Yeah? Okay. So we did one like this earlier, didn't we? Yeah. So I don't know, 1, 2, 3, 4, 5 minutes maximum, I think, for this. Yeah. So I'll give you 5 minutes to do this one now, then I'll do it on the board.
Do you think we should copy the questions too?
Now, the questions are actually on Moodle for this slide. So if you have your phone, you can open this up on Moodle. On the physics page, there's a link called Mechanics, Units and Dimensions, and the link is to these questions. So you don't have to write them down, they're on Moodle. You can look at them that way too. Now just remember in number 1, you can only use the information I tell you about D, T, and M. So even though you know what A is, if you've studied it before, you can't use that. You can only use what I'm giving you.
Can we use the first question?
Yeah, you can use the previous one into the next one, yeah. Which one are you doing?
D.
D, yeah.
A is completed.
You got them finished?
Yeah, I think so.
You think so? You think so? Did you get the G okay?
Yeah.
Yeah? Will we have a look? Yeah? So let's see, the first one. I said U equals D over T. I tell you the D measures length and the T measures time. So the answer is length per time and the unit is meters per second. Okay, so that's okay for A. I hope you got that one. Let's have a look at B. B now. I said V equals U plus AT. Now this is a little bit of a trick. Whatever the dimension is here and whatever the unit is here, that must be the same as this one and this one because we're adding them, so they have to be the same. And actually, you know this one.
Yeah.
So in fact, the answer is the same as A. It's the same answer. It's length per time, and the unit is meters per second. So actually, the answer is the same. Yeah.
Then there's a T, yeah.
For which part? Here?
Yeah.
Well, this is the answer for B. Because whatever this is the same. So I don't actually care about this because I know this one. I know this is the same. So I don't care about it, and that must equal that. How did we do on that one?
Yeah, we got it right first time.
And then you decided to change it and get it wrong the second time? Yeah.
Wait, I don't get it.
What part now?
Okay, the U is ms minus 1, yeah, ms per...
So you're happy with what the U is?
Yeah.
Yeah.
We're adding it to
Yep.
another
Yep.
meter per second.
Has to be because we're only allowed to add things of the same units.
So the final answer would be...
This,
But then you were multiplying the T.
but so you're thinking too much. So if I said to you, A plus B equals C, the unit for B must be the same as the unit for A, true or false?
True.
True. And the unit for C, is it the same as A?
Yes.
Is it the same as B?
Yeah.
Yeah. If I know A, do I care what the B is? No, I don't really care because whatever B is, it's going to be the same as A. But I don't care because I know it'll be the same here as C. So the reason I gave you this question was I wanted you to ignore this. You know, if I said V equals U plus ABC squared over pi, it's enough that you know this. You get the idea for this? Yeah? Okay. Right. C now. What did I ask you for C? Ah, yes, now. Now it's getting interesting. What's the A? Is it?
Clearly not.
You'll have to make it AT equals to B or equals to U.
Yeah, it's from the last question. V equals U plus AT. So what you could say is V minus U over T equals A. That's one way to do it. You could just rearrange this to get the A by itself. Now, you know what the unit for V is, yes? And you know what the unit for U is. And you know they should be the same unit, which they are. And when you subtract them, the unit is still the same. So what is the unit here? It's meters per second, or in other words, length per time. What's the unit here? Time. So in total, we get length per time minus 2, or in other words, meter per second squared, which should sound familiar for this. Yep, if you've studied it before. So this one, yeah, it's getting a little bit trickier now, but that's one way to do it. Another way to do it is you could have said from the last question, well, if I know this is the same. So I could say AT is the same as meters per second, length per time. And you could divide by the T, which is another time. So you get length per time squared. It's the same thing. I prefer to do it this way though. Okay, so this is the answer for C. Length per time squared, which is meters per second squared. Okay, so write this one down. So did we get this one or not?
Yep.
Yeah, no? What did you get?
The first one. Yeah, that's the second one.
You have the backwards?
Yeah.
Okay, so can we go on to D? Yeah, so what am I looking for in D? D was okay. D was F equals MA, and we know the M is mass, and we know the A is length per time squared, yeah. So the answer will be kilogram meters per second squared. That's the unit for F. Yeah, yeah. Okay, so the last one, F equals G M1 M2 over, I think I said D squared?
No, just D.
Oh yeah, you might not see, it's actually a square there. It's very small. Okay, so,
We ignore the G.
which one? We want the G.
We ignore.
Oh no, in this case I actually want the G.
Oh.
So what I can do is I can rearrange it. I can say F D squared over M1 M2 equals G. If I just bring this one up and those two down. Now, what is the unit for F? Well, we have that from earlier. Kg meters per second squared. So it's mass, length, time squared, and then D squared would be length squared, and then here we have mass and mass. Now, I can do some cancelling. This cancels with this. Here I have an L, and here I have an L squared. So altogether I have L cubed, T minus 2, M minus 1. So the answer would be meter cubed per second squared per kilogram is the answer. So this is the dimension, and then this is the unit then. That one was getting trickier. But I'm just giving you the basic idea on how to find what units are in formulas and what dimensions are in formulas. In the exam, when you give your answer, you must include the unit in your answer. Losing the unit will cost you 1 mark. Okay? So you must have the unit in your answer, and if you don't know what the unit is, you need to work it out. Okay? Units are not optional. You must have the unit. Alright. Okay, that was a little bit tricky at the end. So now let's have a look at the question number 2. So this one, I want you to convert this area from millimeters squared, firstly into meters squared, and then secondly into centimeters squared. So we'll do this in 2 parts. Let's just do meter squared first, okay? That's not too bad. If you can give it to me in meters squared first. You got it? Yeah. Oh, you don't have calculators, do you? You'll have to use your phone or something. You won't be able to do this without a calculator. Well, actually, no, that's not true. You could do this without a calculator if you're careful. You have an answer over there? Yeah? You have an answer? Not yet? How big is milli?
It's 0.301. Yeah.
3 zeros or 2 zeros? 0.001. Yeah. You're thinking 10 to the minus 3. Okay, let me start it anyways. What was it? 62370 millimeters squared. Okay, so the first thing, this is equal to 62370 milli squared meter squared. Now actually, by the way, if you're wondering what's the difference is not clear there. I should make it clear. What's the difference between milli and meter? Because they look the same. Does anyone know the difference? Yeah, but maybe I meant meter or milli. Like, how do you know if I wrote m, how do you know if it's milli or how do you know if it's meter?
You can't add the power to the suffix.
You could, yeah. Like meter per second squared. Oh, to the prefix, yeah. No, you could. I'll tell you the difference, okay? Meter is like this, but milli is supposed to be italics. Supposed to be. I won't write it like this, of course. But if you're typing it, when you type it, or if you read it, the difference is meter is in normal font, but milli is in italics, which is at an angle. Anyways, that's not important right now. So we have milli squared meter squared, which will be 62370 0.001 squared meter squared. Okay, this will be 62370 times 0.000001 meters squared. What's that now? 6, isn't it? 1, 2, 3, 4, 5, 6. 0.06237 meter squared is the final answer. Yeah. Okay, you should write that down. How did you do on this one now? Was okay? Yeah. So the next one's trickier. The next one we want millimeter squared to centimeter squared. Okay, so here was a little easier. This one's a bit harder. Centimeter squared.
We can use what we did in
You can, yeah. If you want to use part A, you can, yeah. Tricky, yeah?
Yeah. I don't know if multiply it, right?
Okay, I think I'll do this one because it is tricky. So you might need to see it for the first time. So we still have 62370 millimeters squared. Okay. So this is equal to 62370 milli squared and meter squared. So just like last time, we can go through the steps and we end up with, what was it, 0.06237 meters squared, just like the last answer. But this time, so I'll just write etc. like last time, but this time we need to continue. We're not finished. What unit do I want at the end? Centimeter squared, not meter squared. So here's the trick. I want this here to be centi squared. True? If I put centi squared here, I must balance it by putting centi squared here so that they still cancel. So I'm not changing the answer. This is a little bit like in maths, you know, when you have something like 1/4 and you multiply the top and bottom by 2 to make it 2/8. It's still the same, isn't it? Yeah. So this is the trick here. So this will be 0.06237 over 0.01 squared, and then this can be written as centimeter squared, which is perfect because that's what you want. So now I just need to clean this up. So this will be 0.06237 over 0.0001, which is 1, 2, 3, 4. Is that right?
623.
Yeah, 1, 2, 3, 4. Yeah. 623.7 centimeters squared is the answer then. So this was the trick here. I think was confusing people. Now I know this is different to how you did it in high school, but like I said, I still think this is the best way to do it, because once you practice, this method needs the least thinking. Once you know this trick, then it's not a problem anymore. I don't even know how you would do it any other way. I mean, I can imagine, but it just doesn't seem easy. Yeah. Okay. Is that okay? Yeah. So we have one question left. Number 3. So this one here, I give you the mass of hydrogen. Maybe you know this word hydrogen from chemistry. I tell you the mass is roughly 1.67 times 10 to the minus 27 kilograms. And the hydrogen is a small ball of this radius. And I want to know the density. Firstly, in kilograms per meter cubed. And secondly, in grams per centimeter cubed. And I also give you the formula for volume. It's 4 over 3 pi r cubed. You know the shape?
Yep.
Sphere?
Ball.
It's just a ball, yeah. And I give you the volume here. So you will need the calculator now for this one. So you can probably use your phone. If you have a smartphone and if you turn your phone sideways, it will go as a science calculator. You'll need the calculator for this one. So if you can try A and B. Did it convert to science? Great. So I'll remind you that density is mass over volume. You don't need to do anything special for part A because the units are the usual units of kilograms and meters, so you can just use the formula directly. It's in part B that you have to convert. Okay, we should have part A, especially if you have a calculator. Let me write it down. Part A, density is mass over volume. And I give you the formula for volume. It's 4 over 3 pi r cubed. Can someone just tell me what the mass was? What was it?
1.67
Yeah.
times 10 to the power negative 27.
Okay, and that's already in kilograms, so that's fine. And radius is also in meters, so that's fine. Divided by 4 over 3 pi.
5.29.
Yeah.
Times 10 to the power negative 11.
Cubed. All right, so I'll just put this in on the calculator.
2,693.
Sounds about right. It should be in the thousands. Let's double check. Yep. 2693 kilograms per meter cubed. Okay, now try part B, where I want you to convert this into grams per centimeter cubed. somebody knocking?
To the question page?
Oh yeah. I want it in grams per centimetre cubed. So basically, all I want you to do is to take this answer and to convert it into grams per centimetre cubed. Okay, have we got that converted? Have an answer? Yep. What answer did you get? Good, yeah. Oh no, I think something went wrong with your powers there. Do we have an answer? Possibly.
Oh yeah.
You have an answer, do you? Let's have a look. Okay, so what should I do first? What do you think? Any ideas? First step? Which one to change?
Change the kilogram to gram.
The K, yeah. First thing I'll do is I'll change that K into 1000. You see that? I changed the K into 1000. So that makes 2693000 grams per meter cubed. Now I don't want grams per meter cubed. What do I want? Grams per centimeter cubed. So what do I need here? Centi minus 3.
And we keep another one with the bottom.
That's it. Centi minus 3. So I'll have 2693000 over 0.01 minus 3, whatever it is, yeah. And then here I have grams per centimeter cubed. So actually I'm finished. I just need to hit this in on the calculator. So you can do it by pen and paper, but if you're feeling lazy, you just put it on the calculator and you get 2.693 grams per centimeter cubed in the end. Is this confusing? It's okay? You don't seem like you like it. No? What's confusing? Is it this business with the C and the C?
Yeah.
I can't think of what's a better way to do it than this way.
It seems good, but it just needs
You need
a lot
to
of
practice.
Yeah,
You need to practice, yeah.
It's very new.
So this was supposed to be your homework, so what I'd recommend doing is you could try doing the questions again, and then you can compare them because you have the answers. You can see if you can do them. Yeah. Okay. So we still have a little bit of time, so what I'll do is I'll just start the next topic for a few minutes, and I'll close this down. So there's no homework from this lesson, but like I said, if this is new or confusing, you might want to try the questions again and you have the answers to check them. Okay? Because it's good, it's a good method if you practice how to do it. Yeah. Okay, so let me just close